Now, the bracket as shown below is to carry a load of 45 kilonewton. Determine the size of the rivet if the shear stress is not to exceed 40 megapascal. Assume all rivets of the same size. So they have given you the spacing here 100, 100, 120, 120. So you have to label it as 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, altogether there are 9 rivets here. Okay, so here I have 1, 2, 3, 4, 4, 5, 6, 7, 8, and 9. And then you see, okay, each of the rivet, I have a primary shear force or a primary shear load drawn, okay, on each rivet except this one. This one you should draw, okay, a vertical arrow acting downwards also to represent the primary shear load due to this 45. Okay, then you have this, and this. Okay, so all the rivets, you have a primary shear load of 45 divided by 9. 45 divided by 9, so you have 5 kilonewton, 5, 5, 5. Each of these PS here carries a primary shear load or a direct shear load of 5 kilonewton. Each carries a load of 5 kilonewton. Now, in this question here, we can straight away locate our CG. So therefore, we can skip that step of finding out the CG for the riveted system. Now, we know that the direct shear load on each rivet, so you need to take the 45 kilonewton just now, the 45 kilonewton, go on. So you need to take the 45 kilonewton that is acting here just now, divided by 9 rivets. Okay, so altogether you have 5 kilonewton each, 5 kilonewton each, 45 kilonewton. So you have 5 kilonewton each, or 5,000 newton. Okay, so the direct shear load acts parallel to the direction of the load. So remember earlier, you have the load that is acting, okay, on the bracket that is 45 kilonewton. P, which is 45 kilonewton, that is acting vertically downwards. So all these arrows here, PS here, should be parallel to what you have. Okay, should be parallel to the direction of the load P. Okay, so and then you find the turning moment produced by the load P due to the eccentricity E. So you have the P45 multiplied by the E, okay, the eccentricity. So the eccentricity is 500 mm. So all dimensions here is in millimeter. Okay, so this is 500 mm. So you want to convert it to meter or remain as mm, up to you. Okay, so you have 45 kilonewton times 500. So you got the turning moment of 22.5 times 10 to the power of 6 Newton millimeter. Now this turning moment tends to rotate the joint about the center of gravity G of the rivet system in a clockwise direction. Okay, in a clockwise direction. How will we know that it is clockwise or anti-clockwise? So it depends on the load P that is acting here just now times the eccentricity. Okay, so if you take moment about CG here, the center of gravity, so this P here, the line of action of 45 kilonewton is acting downward. So acting downward, so the arrow is pointing downward. So take moment turning about point G. So it will give you a clockwise turning. Okay. So due to this turning moment, secondary shear load on each rivet is produced. Secondary shear load, that is your F1, F2, F3, F4. Okay. So you can see the direction of turning is in clockwise direction as well. Okay, so before you can draw the F1, F2, F3, okay, F6, F5, F4, okay, and then you have this F9, F8, and F7, all in clockwise direction. So that is why you don't see the secondary shear load here. Okay, all in clockwise direction. All in clockwise direction. So before you can locate these forces, secondary shear forces, you have to draw all these radial lengths here, connecting it to the CG point. So remember, your F doesn't show here because it doesn't give you any turning moment, because the distance is 0. So all this has a distance, length L1, length L2, length L3, L6, L4, L7, L8, and L9, but 5 don't have radial lengths, okay? So now remember, all these forces here, secondary shear force that is denoted by F, okay, have to be perpendicular or 90 degrees to the radial length. Have to be 90 degree, okay? So due to this turning moment, secondary shear load on each rivet is produced. It may be noted that rivet 5 does not exist any moment, okay? Rivet 5 does not exist any moment. So you have F1 to F9 except F5. Now be the secondary shear load on rivets 1 to 9. Okay, 1 to 9 except 5. Okay, and then the distances of L1 to L9 except L5 from the center of gravity G of the rivet system as shown. Now from the symmetry of the figure, we know that L1, L3, L7, L9, you can use Pythagoras theorem in order to find out these lengths here. L1, L3, L9, and L7. Okay, so by using Pythagoras theorem, you will be able to find the radial lengths of L1, L3, L7, L9 as 156.2. Then use this formula here, okay, which now you have F1 to be the subject. So with all the L1 to L9 here, you have already known except L5 is 0. L5 is 0, okay? L1 to L9. Then P times E you have already found, which is in Newton millimeter. Eccentricity is 50, P is 45 kilonewton, eccentricity is 500 mm. So F1 is the subject, so you will be able to calculate your F1 from this formula. So based on these steps here, you will come to F1 equals to 23,120 Newton. Okay, since the secondary shear load are proportional to their radial distances, so the F is proportional to the L, okay, from the center of gravity. So you can, once you have found out F1, you can find out F2, F3, F4, F except F5, F6, F7, F8, and F9. Okay, so L2, L8 is the same. So therefore, F2 and F8 is the same. L3, L7, L9, and L1 is the same. Therefore, it is 23120. Okay, so the forces, secondary shear forces are the same once the radial length is the same. L4 and L6 radial length is the same. So F4 and F6 is the same. Okay, so the secondary shear load acts perpendicular to the line joining the center of the rivet and the center of gravity of the rivet system. And their direction is clockwise. So by drawing the direct and secondary shear load on each rivet, we see that rivets 3, 6, and 9 are heavily loaded. 3, 6, and 9 are heavily loaded. Now, the easiest way to see is look at this diagram here. So 3, 6, and 9 is the closest to the load 45 kilonewton. So therefore, we assume that these 3 rivets will pick up the maximum load. So that is why when we do the analysis or when we do the calculation for the resultant, we only consider 3, 6, 9. Okay, and then also at the same time, we have to find the cos theta 3, cos theta 9. Okay, so because we need those. Okay, so cos theta 3, cos theta 9. Okay, so R3, R9, and R6 you have. Okay, R3, R9 you need to use this formula. R6 you don't have to. You look at the diagram, R6, yes. Okay, so the PS and the F6 is acting in the same direction, acting downwards. So you need to take PS plus F6. PS plus F6. Okay, so you see here, PS plus F6. So 19,800. So as you compare R3, R9, and R6, of course, R3 and R9 has the maximum load. Okay, so you just use the maximum resultant, calculate or find out the diameter. Now, this is your shear stress. Okay, find the diameter of the rivets. So 29 millimeter. Okay.